In this video, we'll discuss how to allocate GPUs on the NIH Beowulf cluster using the Slurm batch system. GPU stands for Graphics Processing Unit, and these specialized processors were originally developed for graphics-intensive operations, primarily in the gaming industry. Over time, it became clear that they could also be used in high-performance computing applications, and vendors introduced features that made GPUs more generally useful. In compute nodes, GPUs exist as coprocessors along with more typical CPUs, but their highly parallel architectures allow very high rates for numerical processing. Keep in mind that application code must be written specifically to utilize GPUs, generally using specialized libraries such as CUDA or OpenCL. This schematic demonstrates that during program execution, sequential code continues to be executed on CPUs, whereas code which is highly parallelizable runs on GPUs. Programs available on Beowulf which utilize GPUs represent a number of application domains, including molecular dynamics, image analysis, deep learning, and others. And this list will undoubtedly grow with time. In a previous video, we saw how the batchlim command can be used to view available partitions on the cluster and limits associated with each. One of those partitions is the GPU partition, here showing a default wall time of 2 hours, a max wall time of 10 days, and a per-user limit of 48 GPUs per user. Keep in mind the type of partitions and their limits will change from time to time, so it's a good idea to run batchlim every once in a while to see what the current limits are. There are currently 4 types of GPUs available on Beowulf: the NVIDIA K20X, K80, P100, and V100. The composition of GPU types on the cluster will change with time. So how could you determine the available types of GPU without resorting to documentation? Here's how. In a previous video, we've seen the freen command used to list the various node configurations and their partitions. If we pipe the output of freen and grep for the string GPU, we'll discover all node configurations containing GPUs. In this excerpt from the command's output, we see that there are 4 different node configurations in the GPU partition. Also listed are the number of GPUs per node and Slurm features. One of those features is prefixed by the string GPU, and following the GPU prefix is the GPU type. You'll need this GPU type to allocate GPUs as shown in the next slide. To submit a batch job which will allocate GPUs, use 2 options to the sbatch command. The first is --partition, and this will always be set to GPU. The other is --gress. Gress stands for generic resource. There are 3 parts to this gress separated by colons. The first is the resource type, and this will always be GPU. The second is the GPU type, and these are the types discovered in the previous slide. At the moment, there are 4 choices: K20X, K80, P100, and V100. And the third part is the number of GPUs to allocate per node. This must be between 1 and the maximum number of GPUs on a node. You can also allocate a GPU in an interactive session. In this case, you don't specify the partition name. On this slide is summarized the type of GPU-equipped nodes in the Beowulf cluster. The table lists the GPU type, total number of nodes, total number of GPUs, the number of GPUs per node, the number of CPUs per node, and this last column shows the number of CPUs that are bound to each GPU on the node. Recall from my previous video that Slurm uses the Linux kernel to bind a process to a specific set of compute cores and memory. Similarly, it binds a number of CPUs to a specific GPU. So one thing to be careful about is to not try to allocate more CPUs per GPU than is possible for a given node configuration. For instance, specifying CPUs per task equals 16 while requesting a single K80 GPU. On those nodes, each GPU can be allocated a maximum of 14 CPUs. This last slide shows the results of a molecular dynamics benchmark using the molecular dynamics program NAMD and simulating the STMV molecule. On the x-axis is shown the number of nodes used in the benchmark, and on the y-axis is shown the number of compute days needed to simulate a nanosecond. The red curve shows the result using Haswell CPUs. The green and blue curves show results using nodes equipped with K20X and K80 GPUs, respectively. The results show two things. First, single node performance of the GPU nodes is significantly better than CPU only. But second, note the better scaling of the CPU only nodes. The K80 nodes don't really scale beyond one node, and the K20X nodes fall off after 3. In contrast, the CPU only nodes show good scaling up to 32 nodes. This is just another example of why it's so important to benchmark your code with your data. And with that, we conclude this video.